Section 6 of National Geographic Magazine, Volume 1, Number 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Report Geography of the Sea, Part 2, by George L. Dyer. Tidal Phenomena. The causes for many of the inequalities in the tidal elements observed at different places have not yet been satisfactorily explained. The phenomena are dependent on many purely terrestrial conditions. While we are able to ascertain with tolerable accuracy from certain constants, derived from observation, the times and heights of the tides, the problem to compute theoretically the tides of an ideal ocean of known depth and configuration remains still unsolved. According to Farrell, our present knowledge of tidal phenomena is comparable to that possessed 2,000 years ago of the science of astronomy. Temperatures of the sea. The temperature of sea water had already been observed by Ellis in 1749 in the Atlantic, and subsequent expeditions have furnished a great number of temperature observations in various seas and various depths. The diversity of instruments and of methods employed by the earlier observers and the faulty methods of recording have made the uniform reduction of many of these observations difficult or impossible. The most complete and valuable collection of these older observations up to 1868, with an account of the instruments and methods used by each observer, was published by Prestwich in 1876 in the Philosophical Transactions, Volume 165. With the advent of the great scientific expeditions, which were supplied with modern and refined instruments, our knowledge of the thermal conditions of the sea has progressed immensely, and we are now able to construct charts of all the oceans showing the distribution of the isotherms with considerable accuracy. The annual average surface temperature has been found higher in the Indian Ocean than in either the Atlantic or Pacific. The North Atlantic is slightly warmer than the North Pacific, but the South Pacific is warmer than the South Atlantic. This holds generally good also for the temperatures between surface and bottom. The temperature generally decreases more or less rapidly from the surface down to about 500 fathoms, at which depth it is quite uniformly between 39 degrees and 40 degrees Fahrenheit. From that depth it decreases slowly towards the bottom, in the polar seas to between 27 degrees and 28 degrees Fahrenheit, in the middle and higher latitudes of the northern hemisphere, and at depths of 2,000 to 3,000 fathoms to between 34 degrees and 36 degrees Fahrenheit. At the equator and in southern latitudes it remains in the neighborhood of 32 degrees Fahrenheit. The low temperatures at the bottom are thought to be due to a steady but slow circulation of water from the polar seas towards the equator, and where the circulation is most free and unobstructed, as in the South Atlantic, South Pacific, and Indian Ocean, the bottom temperature is slightly lower than in the North Atlantic and North Pacific, both of which are connected with the polar sea by comparatively narrow and shallow straits. The theory of this circulation from the polar seas is greatly strengthened by the facts appearing from the investigation of the bathymetric isotherms in enclosed seas, i.e., seas which are separated from the deep oceans by submarine barriers. In such seas the temperature decreases slowly from the surface down to the depth of the barrier, and from there on remains constant to the bottom. The influence of currents on the surface temperature is very marked, cold currents bending the isothermal lines towards the equator, and warm currents bending them towards the poles. The seasonal changes in surface temperatures are considerable, being the least in the tropical zones. In the Atlantic Ocean, the maximum surface temperature lies near the coast of South America, between Para and Cayenne, and another maximum occurs near the west coast of Africa, between Freetown and Cape Coast Castle. The Pacific Ocean shows the peculiarity that the surface temperatures on the western side are lower than those on the eastern side. Between 45 degrees north and 45 degrees south, the temperature does not fall below 50 degrees, but between those parallels and the poles it remains most always below that figure. The warmest water is found in the Red Sea, where the surface temperature has been recorded as high as 90 degrees. North of the equator, the mean annual temperature is considerably above 80 degrees, but south of it, to about the parallel of 25 degrees, it varies from 80 degrees to 70 degrees. Chemical composition, salinity, and density of seawater. In this branch of inquiry, great progress has been made, and seawater is now known to contain at least 32 elementary bodies. Its chief constituents are found to consist of the chlorides and sulfates of sodium, magnesium, potassium, and calcium. It also contains air and carbonic acid. The salinity and density of seawater have been investigated very thoroughly, particularly in the Atlantic. As the salinity of the seawater is an index of its density, changes in the former naturally affect the latter. The salinity has been found generally to decrease in the neighborhood of coasts, where rivers discharge their water into the sea, and it is a maximum in the trade zones and a minimum in the equatorial rain belt. The salinity is affected by the degree of evaporation and by the frequency of rainfall, and is now recognized as an important factor in the biologic conditions of the sea. Of the three great oceans, the Atlantic, with a salinity of 3.69%, shows a slight preponderance over that of the Pacific and Indian Ocean, whose average salinity is 3.68 and 3.67, respectively. In the trade belts, the great evaporation augments the salinity, and hence also the density, and in the polar zones the formation of ice brings about the same result, though in a lesser degree. In the equatorial calm region, the frequent rainfall diminishes salinity and density through the dilution of the salt water. Density and salinity are thus in a certain degree subject to seasonal changes. In the Atlantic, the density increases in general from the higher latitudes towards the equator, but the maxima are separated by a zone of lesser density. The maximum in the North Atlantic Ocean is found between the Azores, the Canaries, and the Cape Verde Islands, and the minimum between the equator and 15 degrees north. In the South Atlantic, two maxima occur, one to the north of Trinidad, and the other near St. Helena, and between that island and Ascension. Taking pure water at 4 degrees Celsius for unity, the maximum density in the Atlantic is 1.0275, and in the Pacific 1.0270. In the North Pacific, the maximum density occurs between 30 degrees and 31 degrees north, and the minimum in about 7.5 degrees north, in the equatorial countercurrent, where it was found as low as 1.02485. In the South Pacific, which has a slightly greater density than the North Pacific, the maximum has been found in the vicinity of the Society Islands. The density of the waters of the Indian Ocean is not yet as well known as that of the Atlantic and Pacific, but the results ascertained indicate a lesser density in its northern part, with a maximum in the region between 20 degrees and 36 degrees south, and longitude 60 degrees to 80 degrees east. In the vicinity of Java and Sumatra, probably on account of the extreme humidity of the atmosphere and of frequent rainfall, the density has been found as low as 1.0250. In regard to the density of the water at various depths, it has been ascertained that as a general rule it decreases from the surface down to about 1,000 fathoms, after which it increases again slowly to the bottom. In the equatorial calm regions, however, where the heavy rains dilute the surface water, the density decreases from the surface down to between 50 and 100 fathoms, after which it follows the law found for other parts of the ocean. The bottom densities of the South Atlantic and Pacific have been found about alike, varying only from 1.02570 to 1.02590. Those of the North Atlantic, however, show a greater value, varying from 1.02616 to 1.02632. Greatest depths of the oceans. Atlantic. Rejecting some of the earlier soundings as untrustworthy, the greatest known depth in the North Atlantic is to the north of the island of Puerto Rico, in about latitude 19 degrees 39 minutes north, longitude 66 degrees 26 minutes west. Found by the CSS Blake, Lieutenant Commander Brownson, USN, in 1882-83, 4,561 fathoms. The deepest known spot in the South Atlantic is 3,284 fathoms in about latitude 19 degrees 55 minutes south, longitude 24 degrees 50 minutes west, sounded by the USS Essex, Commander Schley, in 1878. The general run of the soundings indicates that greater depressions exist nearer the western than in the eastern or middle part of the Atlantic north and south. Pacific. In the North Pacific, the greatest depression has been found by the USS Tuscarora, Commander George E. Belknap, USN, in 1874, 4,655 fathoms, in latitude 44 degrees 55 minutes north, longitude 152 degrees 26 minutes east. The next deepest sounding in the North Pacific was located by the Challenger in 1875, 4,475 fathoms, in latitude 11 degrees 24 minutes north, longitude 143 degrees 16 minutes east. As in the Atlantic, the greater depths appear to exist in the western part, and particularly off the coasts of Japan. In the South Pacific, the greatest depths were supposed, up to a recent period, to be in the eastern part. Within the last 2 years, however, the British surveying vessel Egeria has discovered greater depressions in the western part of the South Pacific. One spot, sounding 4,430 fathoms, in latitude 24 degrees 37 minutes south, longitude 175 degrees 8 minutes west, and another 12 miles farther south, 4,298 fathoms. Indian Ocean. In this ocean the greatest depths appear to exist to the north and west of the Australian continent, where there are more than 3,000 fathoms in a number of widely separated spots, indicating a depressed area of considerable extent. In the most southerly part of the Indian Ocean, or rather in the Antarctic region, the Challenger obtained in 1874 a maximum depth of 1,673 fathoms, in latitude 65 degrees 42 minutes south, longitude 79 degrees 49 minutes east. Arctic Ocean. The greatest depth was sounded by the Sophia in 1868, 2,650 fathoms, in latitude 78 degrees 5 minutes north, longitude 2 degrees 30 minutes west. In the minor seas, the maximum depths so far as ascertained are: Caribbean Sea, 3,452 fathoms south of Great Cayman; Gulf of Mexico, 2,119 fathoms, Sigsbee Deep; Mediterranean, 2,170 fathoms; North Sea, 375 fathoms; Baltic, 178 fathoms; China Sea, 2,100 fathoms. Coral Sea, 2,650 fathoms. Sulu Sea, 2,550 fathoms. Celeb Sea, 2,600 fathoms. Banda Sea, 2,800 fathoms. January 1889. End of section 6.